Hello guys, this is Wits Lounge, Learning Made Easy, and in today's video we're going to be understanding the formulas to solve solubility in mole per dm³. The mathematical expressions we are going to be discussing will be strictly dependent on the units of solubility. So we're going to be taking the units of solubility and bring out mathematical expressions that can be used to solve questions based on them directly. So let's look at the screen. Now, let's start with the first one. The first unit of solubility, which happens to be the most popular unit of solubility, is mole per dm³. So in mole per dm³, what are the different mathematical expressions that can be used to solve these questions? When you are asked to find the solubility in mole per dm³, the mathematical expression we are going to be using to solve it is dependent on the unit of the solute and the unit of the solvent. What I'm basically going to be doing is not minding the unit of the solute given. I simply convert it such that it suits mole per dm³. Remember, general solubility formula, solubility S is equals solute all over solvent. But remember, this solute is max, and then it has to be at a particular temperature. Let's leave that and come back. So solubility mole per dm³ is dependent on the solute and the solvent. The formulas of solubility in mole per dm³ are strictly dependent on the units of the solute and solvent. So let's look at different units and create the mathematical expressions for them. Okay, so let's start with the first one. If the solute is in mole and the solvent is in volume in dm³, you find out that this one will be very simple. It simply means that solubility in mole per dm³ would be equals, now remember, solubility is solute on top, solvent. It would be solute in moles divided by solvent in dm³. So in a scenario where your solute is mole and your solvent is in volume in dm³, just do the solute in mole divided by the volume of the solvent in dm³, and you have your solubility in mole per dm³. Okay, let's try out a question to help us understand that. The question says 2 moles of sodium chloride was dissolved in 0.5 dm³ of water at 25 degrees Celsius. What is the solubility of sodium chloride at that temperature? Quite simple. So let's solve. Now, and if you notice, writing out our parameter solution, the solute is 2 moles of sodium chloride. Solvent is 0.5 dm³ of water. So what does this simply imply? It simply implies that when we are looking for the solubility in mole per dm³, as we said, when the solute is in mole and solvent is in dm³, we simply solve it directly by solute in moles divided by solvent in dm³. Now, with that said, this is going to be equals, what's the solute in mole? Solute in mole is 2 moles. What's the solvent in dm³? 0.5 dm³. So eventually, our solubility in mole per dm³ would be equals 2 divided by 0.5 will give us 4 mole per dm³. Quite simple, right? You see, so that's actually quite easy to understand. Now, the next scenario that could come up is a scenario where your solute, so the next condition is if solute equals mole and solvent is equals volume in cm³. What's going to happen here? Now remember that our solubility unit must be mole per dm³. So if your solute is not in mole, you convert it to mole, and if your solvent is not in dm³, you have to convert it to dm³. So just as in this case now, our solvent is not in dm³. As you can see, this is not dm³. So what do we do about that? Very simple. There is a simple relation between volume in dm³ and volume in cm³, and it is simply expressed as volume in dm³ is equals volume in cm³ divided by 1000. What does this simply mean? It means that anywhere I need the volume in dm³, I can simply replace it by volume in cm³ over 1000. Generally, solubility in mole per dm³ is mole divided by volume in dm³. But because I have my volume in cm³, I can generate a new mathematical formula from that, and that is, if volume in dm³ is equals this, my solubility in mole per dm³ can actually take a different turn, and that will now be amount of solute in mole divided by, I don't have a volume in dm³, but I have a volume in cm³, and the relationship between dm³ and cm³ is volume in cm³ over 1000 of solvent. So you'll notice that if I decide to rearrange this is now going to be solubility in mole per dm³ would now be equals amount in mole divided by volume in cm³ over 1000, and automatically this is going to be equals solubility in mole per dm³ would now be equals, amount in mole is represented by n, so let's use that n. Instead of division, you write multiplication, then take this up and bring this down, times 1000 all over volume in cm³. So you have that. So you have that. Anytime you are asked to solve for solubility in mole per dm³ and you are given the solute in mole, but your volume is in cm³, instead of simply writing volume mole over volume in dm³, you rewrite it as number of moles divided by volume in cm³ times 1000. This would give you the equivalent to this. So let's try out a question that has to do with that. Now, if for instance you are given a question and the question is, a 250 cm³ saturated solution of sodium chloride at 14 degrees was evaporated to dryness to give 0.8 moles of the salt. What is the solubility of the salt at the initial temperature? So let's get to solve this. Now, in this question, you will notice that our solute is equals 0.8 moles. How do we know? That is the amount that was gotten eventually after it was dry. So I told you that the mass that is associated with, or the amount of a solute that is associated with a saturated solution, is what is going to be used to resolve its solubility, and this is the amount of solute that is associated with that saturated solution in the question. So that's 0.8 moles of the solute. Now the solvent in this case was 250 cm³. Now I might not have mentioned this, but please note this, that the volume of an aqueous solution is equivalent to the volume of the solvent. The volume of an aqueous solution is equivalent to the volume of the solvent, which means whenever you have an aqueous solution and its volume is given, the volume of that aqueous solution will be the same thing as volume of the solvent. So in this case, the volume of the solvent is equivalent to 250 cm³. Okay, now with this said, our solute is in mole, our volume is in cm³. The mathematical expression we're supposed to use is solubility in mole per dm³ would be equals number of moles of solute divided by volume in cm³ multiplied by 1000 over 1, and we have that because that's the expression we got. Now the other way to solve it is convert this to dm³ and then dissolve without using the 1000, but you know, we have a straightforward formula generated here, so let's use it. That's going to be solubility in mole per dm³ would now be equals, the number of moles in this question is 0.8 divided by the volume in cm³ is 250 multiplied by 1000. So let's get to work. 250 here is 1, 250 into 1000 is 4, and 4 times 0.8 will be 3.2 mole per dm³. So you notice that even though we use the volume in cm³ here, because of this 1000, automatically it has converted it to dm³. Please do not misplace this. Remember, we had to do or go through a mathematical procedure to derive this particular formula. So you have this, that whenever solute equals mole and solvent equals volume in cm³, this is the right formula to use. And that's that. Quite simple, right? Let's go to the next scenario. The next scenario we're going to be considering is a situation in which you have your solute in gram and your solvent in dm³. So let's look at it to see what we mean. So if solute equals mass in gram and solvent equals volume in dm³, you will find out that our solubility in mole per dm³ will not be expressed as number of moles all over volume in dm³ anymore. So what do we actually do to resolve this? Quite simple. Now, the mass has a relation to number of moles. So what we need to do is convert this mass to number of moles, and that's actually resolved. What is the relationship between mass and number of moles? Number of moles is equals mass over molar mass. So which simply means that if I have mass in the question and I need to replace it with number of moles, what do I need to do? Instead of writing just mass, I'm going to write this whole lot and replace the number of moles. So which means our solubility in mole per dm³ will now take a different shape, and that's going to be equals, instead of writing number of moles on top, what is going to be here is mass over molar mass. Why? Because in the question I was given mass. Then I'm going to be dividing by volume in dm³. So with that said, the solubility in mole per dm³ will now be simply equals mass over molar mass. Now changing the division to times would mean that I will need to invert this particular volume in dm³, so which makes it 1 divided by volume in dm³. So we have that, another formula generated. And what is this formula used, or when is it used? When you have your solubility in mass in gram and your solvent is a volume in dm³, simply use this, mass over molar mass times 1 over volume in dm³. Now, you do not necessarily need to start cramming all these formulas. One thing I will expect you to do is this: just solve questions, and when you solve questions, look up the particular mathematical expression required and use it. By the time you use it over and over, you'll notice that these things will be in your head. So let's move ahead. Let's try a question to help us understand this. The question is, 117 gram of NaCl was dissolved in 1 dm³ of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm³ of sodium chloride at that temperature. So that's quite simple. Now, if we look at the parameters, let's solution, or the things we are given to solve this question. First of all is that the solute is equals 117 gram of sodium chloride, and then the solvent, as seen in the question, is 1 dm³ of water. So having mentioned that, the implication is that we are giving our solute in gram and our solvent in dm³, and we are expected to solve in solubility in mole per dm³. So what do we do about this? Quite simple. I told you that when your solute is in gram and the solvent is in dm³, we simply use the mathematical expression mass over molar mass times 1 over volume in dm³. So where m is mass, mm is molar mass, v is dm³. Okay, so let's get to work. So the mass in the question is given, the volume of the solvent is given, but we don't have the molar mass. So let's first find the molar mass. Now, remember, molar mass of any substance is equals the sum of its relative atomic masses. You can look up our stoichiometric videos to actually understand this. So the molar mass of NaCl is now going to be the sum of the atomic masses of NaCl, which is going to be 23 plus 35.5, and that is going to give us 58.5. So that's the molar mass of NaCl. So let's now apply the formula, which means that solubility in mole per dm³, when we have mass as 117, will be this, divided by the molar mass is 58.5, and then what do we have? Multiplied by 1 over the volume in dm cube is 1 dm cube. So with this said, what are we going to have? If this goes through, I think this should be 2, yeah. And eventually, if it times this, multiplies, divides, you have 2 times 1 divided by 1. We have 2 mole per dm cube. So please note, if your solubility is expected in mole per dm cube, but your solute is in mass in gram, and your solvent is equivalent to volume in dm cube, you simply use the mathematical expression solubility in mole per dm cube equals mass over molar mass times 1 over volume in dm cube. Quite simple, right? Good. So we go to the final expression for solubility in mole per dm cube. And what's that? A scenario where the solute equals mass in gram and solvent equals volume in cm cube. The same thing. Now remember, solubility in mole per dm cube is simply equals number of moles of solute divided by volume in dm cube of solvent. Now, but we have mass and volume in cm cube, so what do? We find an expression that relates number of moles to mass and replace the number of moles, and find an expression that relates volume in dm cube to cm cube and replace it. We already know those things. Number of moles is equals mass over molar mass, and then volume in dm cube is equals volume in cm cube all over 1000. So wherever we have number of moles, we replace it with mass over molar mass. Wherever we have V dm cube, we replace it with V cm cube over 1000. So with that said, we would have that our solubility in mole per dm cube would now be equals number of moles divided by volume in dm cube. Number of moles in this case will now be mass all over molar mass divided by volume in dm cube, which is now going to be expressed as volume in cm cube all over 1000. So if we decide to change this division to multiplication, solubility in mole per dm cube would now be equals mass over molar mass multiplied by, now we have to invert the divisor. Whenever you change division to multiplication, you invert the divisor, which means 1000 will now be on top and volume in cm cube. So we have that. This is the mathematical expression used whenever you want to solve solubility in mole per dm cube and your solute is in mass and solvent is in cm cube. Quite simple, right? So let's try out the question to help us understand this. 10.5 grams of lead 2 trioxynitrate 5 is dissolved in 20 cm cube of distilled water at 18 degrees Celsius. The solubility of the solute in mole per dm cube is dash. Quite simple. Now let's get to the solution. Now if you look at the question, your solute is equals 10.5 gram of PbNO3. Your solute is actually the substance that is being dissolved, and your solvent is the substance that dissolves another substance. So have that in mind. So we discussed this in when we describe true solution, so you can look up that video too. Now the solvent in this case is 20 cm cube of water. So with these two said, if we are asked to find the solubility in mole per dm cube, it's going to be expressed, the mass is given as the solute, so it's mass over molar mass multiplied by 1000 all over volume in cm cube. So have this in your head that when we use this is when solute is in mass in gram and solvent is in volume in cm cube. So let's get to work. Now this implies that we need to find the molar mass of the salt. So the molar mass of PbNO3, as I said earlier, is sum of atomic masses. Pb is 207 plus nitrogen is 14, but then you notice that it is multiplied by 2, so 14 times 2. Oxygen is 16, but it is multiplied by 3 times 2, so that's going to be times 3 times 2. And when we sum this up, this is going to be 207 plus 28 plus about 96, which is equals 331 gram per mole. Okay, so with that said, I think we have everything we need, so let's impute it. So the solubility in mole per dm cube would now be equals, the mass in this question is 10.5 gram divided by the molar mass, which is 331 gram per mole, multiplied by 1000 all over the volume in cm cube is 20 cm cube. So if you do this, we are going to get 1.59 mole per dm cube. Quite simple, right? So you have that. Whenever you are asked to find the solubility and your solute is a mass in gram and solvent is volume in dm cube, simply use this formula straight up and you have your answer. The formula is mass over molar mass times 1000 over volume in cm cube. So that's that about solubility in mole per dm cube.